we're going to learn how to divide polynomials. We spent a lot of time multiplying them. We have not yet talked about how one divides polynomials. Now, in order to divide polynomials, we have to go back to the dividing technique we learned in elementary school. Remember a problem that looks like this? This says 21 divides into 672. And the way that we would do the problem is, because this is 2 digits, we would try to figure out what we can multiply 21 by to get as close to 67 as humanly possible. So you play around a little bit. You do 21 times 1, 21 times 2, 21 times 3, 21 times 4. And you figure out you can get as close to 67 as possible by multiplying it by 3. Oops, I didn't want to quite do that. All right, so 21 times 3 is 63. And then you would subtract these. So 67 minus 63 is 4, and you bring down the 2. And then you would ask yourself, well, what can you multiply 21 by to get as close to 42 as possible? Well, if you multiply by 2, you hit 42 on the nose, and you subtract, and we say that we have a remainder of 0. We didn't always get a remainder of 0 when we learned how to do this process in elementary school. Sometimes that remainder was a number, and we would just write it over here next to the quotient. The word quotient is the answer to a division problem. The process for polynomial division is going to be similar. Here is an example of what a longhand polynomial division problem might look like. I want to divide the expression 2x plus 1 into 6x squared plus 7x plus 2. The reason it's similar is because there are 2 terms in what's called the divisor. And we want to figure out how we can multiply that and get as close to the first 2 terms in the dividend, the part that's under the division symbol. Now, you don't necessarily get it on the nose, but here's a little hint. I always want to turn the first term in the divisor into the first term of the dividend. In other words, what can I multiply 2x by so that it becomes 6x squared? Well, I would multiply by 3x. I want you to notice where I wrote the 3x, because that's really important. Oops. I wrote it over the second term. It's kind of works the same way here. Notice where I wrote this initial 3. I wrote it over the 7 and not the 6. Okay, so now when I multiply 2x plus 1 times 3x, I get 6x squared plus 3x. Guess what I'm going to do to these? The same thing I did in elementary school longhand division. We're going to subtract these. What should always happen if you did this correctly is these terms, the first ones, should always cancel. Be careful when you do this. Now you're going to do 7x minus 3x. And then you bring down the next term. Sometimes students get confused and they forget that you're subtracting because there are multiple terms going on here. You're always subtracting the terms. Okay, now I want to see what I can multiply 2x plus 1 to turn it as close to 4x plus 2 as possible. All I want to do is multiply 2x by something to make it 4x. Well, you multiply by positive 2. So, get rid of these lines. Now I'm going to multiply. 2 times 2x plus 1 is 4x plus 2. And now when I subtract these, 4x minus 4x is 0, and 2 minus 2 is 0. So I again have a remainder of 0. Remainders of 0 are going to be very important in our polynomial division. What they're going to tell us is that if I were to write this polynomial in factored form, this is one of the factors. And if the dividend is one of the factors, then x equals -1/2 is one of the solutions. Remember, you find the solution by setting the factor equal to 0 and solving for x. But this only happens if the remainder is equal to 0. So in problem 1, we're going to use polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5. Now, let me give you a little addendum. Why are we learning polynomial division? Polynomial division is going to assist us in simplifying more complex problems when we get to more complex mathematics. Okay, so how do I write this? Let me start by writing this like we learned it in elementary school. Remember not to confuse the division symbol with the square root symbol. Sometimes students do, so just be careful. The other thing that I want to mention, but we didn't run across it here, was that the polynomial you're dividing into needs to be written in descending order of powers. That means the first term should have the biggest exponent of x, and every term should go down from there. Okay, so I'm going to start with the fact that this has 2 terms. So I want to know how many times it goes into the first 2 terms of the polynomial. The easiest way to do this is, what do you have to multiply x by so that it becomes 4x squared? Well, it's missing a 4 and an x. And notice I wrote it over the second term. Now I'm going to multiply 4x by both of these. 4x squared plus 20x. And then we subtract these. If you've done this correctly, these should always cancel. They should always be 0. The other one is going to be 23x minus 20x, which is 3x. Bring down the next term. Now, I want to find out what I can multiply x plus 5 by so that it gets as close to 3x minus 16 as possible. In other words, what do I multiply x by so that it becomes 3x? I'm missing a positive 3. So now I'm going to multiply both of these by 3. 3x plus 15. And I'm going to subtract. 3x minus 3x is 0, which is exactly what should happen. Be careful. The next one is negative 16 minus 15, which is negative 31. So that's the remainder. And so we would just write the remainder here. The book writes it a little bit different. I like to put a little colon next to it. The way the book wrote it made it look like it said this. I don't like that because it looks like it says r minus 31. So this is the solution. Because the remainder was not 0, this is not a factor. In other words, if you were to graph the original polynomial, x does not cross the x-axis at negative 5. On your own, I'd like you to try dividing 3x squared minus 29x plus 56 by x minus 7. As a matter of fact, I'll help you out. X minus 7 goes on the outside of the division symbol, and underneath of it is the 3x squared minus 29x plus 56. The quotient is the answer to a division problem, and the remainder is, at the very end of the problem, what are you left with? Now, I've already talked about this earlier in the video. If we want to determine if a dividend is a factor of some divisor, or I'm sorry, the divisor is a factor of the dividend, we're going to use longhand polynomial division. If the remainder is 0, then we can say that it's a factor, and if the remainder is not 0, it is not a factor. So, I'm going to write x squared plus 1 here. I'm going to write 3x to the 4th minus 4x cubed plus 12x squared plus 5. Now, here's the deal. Over here, this is quadratic. What it's missing is a term with an x. We actually have to account for it when we do longhand polynomial division. So I'm going to tack in here a 0x. So now it's written in descending order of powers. It has x squared, x to the 1st, no x. So it really has three terms. We don't normally write the 0x because 0 times x is 0, which means that that term is normally not there. But for the purposes of polynomial division, you have to account for it. So we want to know how many times x squared plus 0x plus 1 goes into the first three terms here. Because there are three terms in the divisor, we have to see how many times it goes into the first three terms of the dividend. All right, all I want to do is turn x squared into 3x to the fourth. In order to do that, I need a 3, and I need 2 more x's. And notice where I wrote the answer. I wrote it above the third term. So now I'm going to multiply 3x squared by each of these. 3x to the fourth plus 0x to the third plus 3x squared. And now we're going to subtract these. No matter how many terms you have, you always want the first term to cancel. Now we're going to do negative 4x cubed minus 0x cubed is negative 4x cubed. 12x squared minus 3x squared is 9x squared. Bring down the next term. Well, now that we brought down the last term in the polynomial, that means we're almost done. So now I want to turn x squared into negative 4x cubed. Well, I'm going to need a negative 4, and I need another x. So now I'm going to multiply negative 4x by each of these. Negative 4x cubed minus 0x squared minus 4x. Oh, shoot. I did mess this up. Hold on. Not much, though. Notice that it goes from 12x squared to 5. I forgot that just like I did on the outside, I've got to account for the fact that there's a 0x here. And then I can put 5. The reason this doesn't make a huge change is because this number here is just 0, because I brought down 0. It doesn't change what I multiply by because I still wanted the first term here to be negative 4x cubed. But it does change my answer when I subtract. Good thing I hadn't subtracted yet. All right, negative 4x cubed minus negative 4x cubed is 0. 9x squared minus 0x squared is 9x squared. 0x minus negative 4x is positive 4x. Again, 0 minus negative 4 is a positive 4. Now I'm going to bring down my plus 5. So I actually do get to do this one more time. Now I want to turn x squared into 9x squared. All I have to do is multiply by 9. So now I'm going to multiply all three of these by 9. 9x squared plus 0x plus 9, and we're going to subtract. So these should cancel when I subtract. 4x minus 0x is 4x, and 5 minus 9 is negative 4. Since I have no other numbers to bring down, this is the remainder. The remainder was not 0. If the remainder is not 0, then x squared plus 1 is not a factor. Well, guess what? If I did an example where this is not a factor, then I bet my next problem I am going to get 0 for the remainder. So let's do this again. Is x minus 2 a factor of p of x equals x to the fifth minus 32? If it is, write p of x as a product of two factors. All right, let's just start with the fact that in order to determine if it's a factor, we're going to do polynomial division. If the remainder is 0, then x minus 2 is a factor. When we go to write this, though, because the first term is x to the fifth, I must account for the fact that there is no x to the fourth, there is no x to the third, there is no x squared, there is no x to the first, but there is a constant. All right, now let's go do our polynomial division. I'm working with only 2 terms at a time. So in order to turn x into x to the 5th, I've got to multiply by x to the 4th. I'm going to multiply x to the 4th by both of these, and I get x to the 5th minus 2x to the 4th. I'm going to subtract. If I've done this correctly, then the first terms always cancel. 0 minus negative 2 is positive 2x to the 4th. Bring down the next term. Okay, to turn x into 2x to the 4th, I need to multiply by positive 2x to the 3rd. So I get 2x to the 4th minus 4x cubed. And then I subtract. These cancel. 0 minus negative 4 is 4x cubed. Bring down the 0x squared. To turn x into 4x cubed, I'm going to multiply by 4x squared. Notice how every time I do this, the power goes down by 1. Did you also notice that when we did this problem, that, oh no, this one didn't work that way. Let's go back. No, never mind. I was going to say that the power goes down by 1. Well, the power of the quotient is always 1 less than the power of the original polynomial you're dividing into, which did happen here. This one, it started with 4, and then this one had a 2, and the reason that happened is because there was a squared there. This one here, the original problem had x squared, and the quotient started with x to the 1st. All right. So now we want to get rid of this 4x cubed, so I need to multiply by 4x. Hold on a second. I feel like something weird happened. Oh, I already wrote my 4x squared. That's what happened. There we go. There's my 4x to the 3rd minus 8x squared. These cancel, and 0 minus negative 8 is 8x squared. Bring down the next one. To turn x into 8x squared, I need to multiply by positive 8x. So I get 8x squared minus 16x. When I subtract, these cancel. 0 minus negative 16 is 16x. Bring down the last term, which is negative 32. To turn x into 16x, I'm going to multiply by 16. I'm going to get 16x minus 32. Wait a second. When I subtract these, I end up with a remainder of 0. That means that x minus 2 is a factor. That means if I were to graph the original polynomial x to the 5th minus 32, the graph hits the x-axis at x equals 2. In factored form, we would write the answer as x minus 2, and then next to it we would write the quotient, which is x to the 4th plus 2x cubed plus 4x squared plus 8x plus 16. This is another way of writing the final answer. On your own, I want you to determine if x to the 4th minus 1 is a factor of p of x equals x to the 5th plus 5x to the 4th minus x minus 5 on your own. However, I'm going to help you get set up. It's kind of a tricky problem because the divisor is really x to the 4th plus 0x cubed plus 0x squared plus 0x minus 1. One thing I'm going to tell you is that whatever the biggest exponent is, the number of terms in the polynomial is always one more. We just don't always write them all because some of them could be zeros. The polynomial that goes under the division symbol, x to the 5th plus 5x to the 4th, there's no x cubed, there's no x squared, but there is an x to the 1st and a constant. And you're going to start by figuring out how many times these 5 terms go into the first 5 terms here. If the remainder is 0, it is a factor. If the remainder is not 0, it is not a factor.